Okay, this lesson may be a little bit long, so please pause if you need to go work some problems and then come back and do it. Okay, to start off with 4.6, we're talking about the quadratic formula and the discriminant. So I'm going to remind you, because I know y'all have seen this before, of where that quadratic formula comes from. So we start off with ax squared plus bx plus c equals 0, which is your standard form of a quadratic equation. And then I'm going to divide everything by a, and that's going to give me x squared plus b over a x plus, and I'm going to have some blank. The other thing I'm going to do is actually take that to the other side, and that's going to give me negative c over a. And whatever I add to this side, I have to add to that side, as y'all have seen me do before. And then we do this process that we're going to talk about in more detail later on. We take 1/2 of this number, and I always write it, 1/2 of that is b over 2a. And I write it like this, and you'll see in a minute why it makes my factoring so much easier, excuse me. And this, when you multiply it out, becomes b squared over 4a squared. Okay, so then when I get to this next step, okay, I'm going to factor, then to factor this perfect square, it's this without the exponent, this sign, and this without the exponent. Quantity squared equals, to get your common denominator, you got to multiply this by 4a over 4a. And if I just rearrange that to my b squared minus 4ac all over that bottom, which is 4a squared. And then what am I going to do? I'm going to take the square root of both sides. And remember, when you take the square root of both sides, of course, the square root of something squared is what you started with, x plus b over 2a. And then you always have to remember to do your plus or minus. And that bottom is already a perfect square, so that's going to become 2a when you take the square root of it. And the bottom is going, excuse me, the top is going to stay underneath your radical, b squared minus 4ac. So then when you bring this guy over to solve for x, you will see that we have negative b plus or minus the square root of b squared minus 4ac all over 2a. And this is the quadratic formula. This is what we use to solve those quadratic equations, which are not so easily factored. So this is the same thing that I would write here, and then I would do an example, but I'm sure y'all don't want to see me do that, so we're going to move on. I'll do one of these because um, you have already talked about this. We talked about them, but I just want to make sure you know how to do it. So let's go with this one. Remember that when you do this, x squared minus 4x plus 13, you got to have everything equal to 0 before you decide that a is 1, b is negative 4, and c is negative 13. So if I put this in, x equals negative b, which is 4, plus or minus the square root of b squared, which is 16 minus 4, times 1 times 13, all over 2 times 1. Now, what's that going to give me is x equals 4 plus or minus something over 2. And so what do we have? We have 16 minus 52. 16 minus 52 is negative 36. So this ends up being the square root of negative 36. And hopefully you remember that's 4 plus or minus 6i over 2, which of course simplifies. 2 has to go into both of these numbers to be able to simplify, so that becomes 2 plus or minus 3i. And that's how we write it. Okay, so moving on, this part of our quadratic formula, I'm going to go highlight it right here, is very special. and it is called the discriminant. Okay, so you can see, and we're going to talk about the different cases of um, b squared minus 4ac being greater than 0 where it's a perfect square, and we have b squared minus 4ac where it is not a perfect square. Okay, and then we have b squared minus 4ac equal to 0, and last but not least, b squared minus 4a being less than 0. Okay, um, hopefully you realize that if it's greater than 0, that of course is when it is positive. Okay, how many roots do we have? We have 2 real rational roots. Okay, that's if it is a perfect square. If it's not a perfect square, then we're going to have 2 real irrational roots because that radical will still be in there. Okay, but your graph will look the same just depending on whether it's rational or irrational. If it's equal to 0, that's when my graph is tangent to the x-axis. So we have 1 real rational solution because obviously there's no radical left. uh, I said solution roots. Y'all know those are interchangeable. And then, of course, here is when your discriminant is negative. And if your discriminant is negative, you need to think to yourself, that means my graph is not crossing the x-axis. So how we describe that now that we know a little bit more is we say we have 2 complex roots. Before you would say not a real solution, but now you know about complex numbers, so we'll say it has 2 complex roots. So you got to pay attention to the directions here. Find the value of the discriminant for each quadratic equation, then describe the number and types of roots. So, of course, a equals -5, b equals 8, c equals -1. So I'm looking at b squared minus 4ac, and that, of course, is 64 minus 4 times -5 times -1. And hopefully y'all can tell me that that is 44. So you had to find the value of the discriminant. That's the value of the discriminant. So what does that tell me? It is not a perfect square and it's greater than 0. So I'm going to have 2 real irrational roots. Okay. I may not fill them in on the video, but I will on the written notes so that you can go back and look at those, okay? So I can make it a little faster for you. So just to review all the different methods that we have talked about in solving quadratic equations, okay? First off, the first method that we talked about was graphing. And it can be used sometimes, but really only if you don't need an exact answer and you always want to check your solutions algebraically. So it is definitely the least preferred method unless you have a graphing utility. Okay. The other thing we have is factoring. And you can always determine if something can be factored by doing b squared minus 4ac. Sometimes it's easy to find out, sometimes not. But b squared, if you want to check and see if it's factored, b squared minus 4ac would have to be equal to 0. Excuse me, not 0. It equals a perfect square. That's what I wanted to say. My bad. I'm going to write PS for perfect square. So you had to listen. Actually, that's probably not a good idea. So let me erase that and write perfect square. If b squared minus 4ac equals a perfect square, then you know that your quadratic can be factored. And I'm telling you, you want to remember that. Okay. Then we had one called the square root property. Okay, and here's the example here. Again, sometimes use x minus 5 quantity squared equals 18. You can take the square root of both sides. That's definitely the easiest way of doing that problem. Okay, then you have another method that we talked about earlier, completing the square. And we did that at the beginning of this lesson. And then, of course, the last, if all else fails, you can always use the quadratic formula, but you need to remember that it is not always the most efficient method of solving a quadratic equation. So it's definitely not something that you want to rely on. Okay, The next section that we have to talk about, transformations of quadratic graphs. We've talked a lot about this, so this should not be difficult for y'all to grasp, and I should be able to go over it quickly. So f of x equals, this is your ax squared plus bx plus c, okay? Now, if that graph has an h in it, excuse me one second. Sorry, little distraction there. We are not using that form of the equation right now. So f of x equals a times x minus h squared plus k. If you have h in your equation, okay, whatever that h value is describes a horizontal translation. And if you have a k, then that describes your vertical translation. Now, like I said, I think we've talked about this enough in class that you get it, but h is always with your x, and you always do the opposite of what it looks like, okay? So it says x minus h, so if it says x minus h, that looks like that's a negative h, but that's really positive, so you go to the right. You do the opposite of what it looks like. K, on the other hand, or excuse me, not k here, I want to write y. Y, k, it always is with the y, no matter what equation we're going to be dealing with. And this one, you're going to do the same as what it looks like in your equation. So if it says plus 2, then you're going to go up 2. If it says minus 2, you're going to go down 2. Okay? Minus 3 says you're going to the right. Plus 3 says you're going to the left. So that's the same and the opposite thing that we've talked about a lot. Okay? And I think you already know that A is talking about just the fact of whether it's positive or negative is referring to the reflection. Okay? Um, and if you're actually talking about the number of A, whether it's larger than 1 or less than 1, then in this case we're talking about a dilation. Okay? And we've talked about this a lot already too, so hopefully that's not something for you to worry about. So let's just do some examples so you know what's being asked. Write each function in vertex form. Okay, now you can it's really going to be easiest to go ahead and complete the square. So when you do this problem, y equals x squared plus 6x plus something, I just move the 2 over and then minus something on the same side of the equation. Half of 6 is 3, squared is 9. So my vertex form here is y equals x plus 3 quantity squared minus 7. Okay? Um, if I do another one, let's go take out a negative 2 here. So this is going to be y equals, take out that negative 2, x squared minus 4x plus something. Okay, I'm just moving the negative 5 over. Now, um, what I like to do is whatever, if there's an a value here, then I'm going to put minus 2, and then I have my blank. Because you got to remember that whatever you put here is inside parentheses in which everything is multiplied by that negative 2. So half of 4 is 2, and 2 squared is 4. So this is going to become y equals negative 2 times x minus 2 quantity squared, and then minus 5 minus, actually it's a minus 2, minus. Okay, if it's plus here, then it's minus over here, but it's a minus, so it actually becomes a plus. Okay? See over here it went plus and then it went minus, but it was times the positive 1. So plus and minus and then times the negative 2 gives me negative 5 plus 8, which is going to be plus 3. So this is the vertex form of your parabola. All right, look at this next example. Which function is shown in the graph? So you have a vertex of negative 3, 6. That says negative 3, 6. This one does not say negative 3, 6. This one doesn't say negative 3, 6. So the difference is whether These both go down, but one of them has a factor of 2. Well, what we've always talked about is if you go over 1, did you go down 1? And we did only go over 1, down 1, over 2, down 4. So we know that the answer to this problem is A. So that's what you got to check out when you are looking at your graphs. Okay, and again, graphing. Okay, we've talked about this before. Y equals x minus 3 quantity squared minus 4. They've done the hard work for us. The vertex is 3, negative 4. You always want to, from that graph, say whether it goes up or down. Okay, so 1, 2, 3, 1, 2, 3, 4. And then remember our key points that we've always talked about. I should write them up here because we did kind of talk about it with that problem. 1, 1, 2, 4, 3, 9. A is equal to 1, so that means I get to use those key points to graph this problem. So if I go over 1, I'm going to go up 1 on both sides. If I go over 2, I'm going up 4 here, count back over and there. And if I go over 3, then I'm going to go up 9, which is going to put me here and here. Now, I got it. We're good. So connect your points to make it look like a parabola. And I do expect y'all to do better than I did. Oh my goodness. This airliner, I do way better on an iPad or on pencil and paper. Okay, so you're good with that one. I will work out both of these. Let's go ahead with number 6 right now, and I'll fill in number 7, just so that I can talk you through one of them. So here, my vertex, I have nothing being added or subtracted to the x, but k is 5. It goes down, okay, and my a value is negative 2. So that means that my key points, instead of, I'm still going to have 1, 2, 3, but my 1, 4, 9 is going to be multiplied by this a value of negative 2, which looks really messy right here. I was trying to make it a little more distinct. A equals negative 2. So 1 times negative 2, 4 times negative 2, 9 times negative 2. So I'm taking these key points up here and multiplying it by the a value. So I go to 0, 5, 1, 2, 3, 4, 5. And if I go over 1, I'm going down 2. Oops, right there. If I go over 2, I'm going down 8. And if I went over 3, I would be off my graph, so I'm just going to make sure that I don't cross that other line. And trying to make it curved and miss it. But you got the idea, okay? And as I said, I'll fill in those other ones so that when you have the notes, you can look at it. Okay, because I think that's what's at the end, just more graphs. All right, last section, quadratic inequalities. I like these things, but you know me. Okay, so in our quadratic inequalities, okay, you have an equation. You're going to graph a quadratic equation. You have to decide whether it's going to be solid or dashed. How do you know whether it's solid? That's if it says less than or equal to or greater than or equal to. And dashed is if it says, if it doesn't have an equal to. Okay? And then you can get a test solution. Okay? This is not a solution if you put it in there and you get a false statement, and if you get it in there and get a true statement. We've talked about this as we do it, and I'm going to go through and do one, and you'll see how we've done it with the y. Okay, so when you're graphing it, you're acting like this is a y, which is why we put it on one set of axes. Okay, um, so we have to go graph that thing. So um, what I want you to do, okay, you can go ahead and factor this. Okay, x plus 6, x minus 1. And I'm hoping that all of y'all realize that tells me that x equals negative 6 or positive 1. So negative 6, 1, 2, 3, 4, 5, 6. I shouldn't have put graphs on here. I should have just put axes, okay? Because all that matters, okay, when you're solving it by graphing is you find those zeros. Now, does my parabola go up or down? If f of x equals that, then I know my parabola goes up. So I know that it has to do something like this. Okay? Y'all, I'm not being exact with it. I'm just telling you that it goes up. So this says 0. This basically says your parabola, where's your parabola? Left, excuse me, less than 0. And less than 0 means that you want negative values. Okay? The function is less than 0. Where's the function less than 0? Okay? If you look on your graph, it's less than 0 all the way in between here. So when I write my answer, that means that it goes between -6 and 1. Can it include those points? It cannot because it doesn't say equal to. So that's your answer. That's an interval notation. If you wrote it otherwise, it would be x between -6 and 1. Either one is acceptable. Okay? Let's try another one because I'm feeling there may be some questions. Okay? I don't like to factor with a negative, so I'm actually going to go through and multiply everything by -1. X squared minus 3x minus 10. I multiply by -1, which means I got to change my sign. And 0 times -1 is still 0. So when I factor this, it becomes x minus 5x plus 2 greater than or equal to 0. Okay? So I'm going to go plot 1, 2, 3, 4, 5, and 1, 2. Now, those are my zeros. My zeros are the same for each of them. Okay? But we're going to go back here and we'll look at this one because that is what I graphed. And actually, it doesn't really matter, y'all. Okay? Um, Whichever one you want to do. But I'm going to go back to this one because that's the original one. And you can see that if you put -2 in here that you're going to get equal to 0. Does this one go up or down? And this parabola goes down. So I'm going back to the original one. And again, all I care about, y'all, is where those zeros are. And this says my function is less than 0. So do I want the positive or negative values? If I'm less than 0, I want the negative values. All right, the negative values on my graph are here and here. Okay, that's where it is. Now keep in mind, this thing is negative and it's going and going and going forever and ever and ever, which means it's going to be negative all the way over there, and it's going to be negative all the way over there. So to write that in interval notation would be um, negative infinity all the way up to -2. Can it include -2? My original has an equal sign, so yes. And then union, and then where do I pick up again? Pick up at 5, and then all the way to positive infinity. Okay? If you wrote that in non-interval notation, you would say x is less than -2 or x is greater than 5. Okay? So, um, those were both negative. Let's go do two more because I want to make sure you understand this. Okay, so this next one, um, oh, yucky yuck. You know what? He doesn't factor, does he? So you got to go find those. Let's look at this one. 28 factors of, okay, hold on. Someone walked in. Okay, so sorry about that. These problems are the same as what you did, but the difference was these are both positive, so that means you're looking for your positive y values on your graph. I will go fill them in, go through the same process that I did, but I want to go on to algebraic so that we can be done because it's been a long video. So, solve each inequality algebraically. So let's do the same thing, similar process, instead of doing the graphing, okay? So what you're going to do, similarly, you still have to set it all equal to 0. So I'm going to have x squared plus 5x plus 6 is less than 0. And then I'm going to factor x plus 3, x plus 2. And then what we generally did, well, we find our zeros. X equals -3 or -2. That's where it's equal to 0. But I really want to know where it's less than 0. So I'm looking for negative values again, okay? But I plot my zeros like I'm on a number line, only the zeros, okay? And then when you have a quadratic, these regions will always alternate, okay? So you can pick a test value, but you can also remember, just like we graphed, if the graph goes up, then it's going to go like this, like we just, so you can think about that. And that means this region is positive, this region is negative. I don't know why I did that, sorry. Oh, Pooh Bear. Anyway, this region's positive, this region is negative, and this region is positive. Put 0 in. I mean, you can figure out a test value. If I go put 0 in, because 0 is in this region, if I put it into this equation, then um, then I'm going to get a positive number. So that's why I put positive here. Okay? If I put negative 2.5, then one's going to be positive and one's going to be negative, which is why it's negative. Okay? I think it's easier to think of the graph because then you don't have to do that calculations. Okay? So if it's negative, then I'm looking for the region on my graph that's negative because of that right there. And so in interval notation, my answer is going to be -3 to -2. Okay, one last problem. Already greater than 0, greater than or equal to 0. So I have x plus 5, x plus 6 greater than or equal to 0, x equals -5 or -6. A little close to what we just did. -6. -6, -5. Okay. So, and you can think of the graph again. Graph goes up, which means it's positive, negative, positive. Um, but if you didn't get that, let's go. Where's 0? 0 is right here. If you plug in 0, this factor is positive, this factor is positive, 2 positive, give me a positive. And it has to alternate. Okay? Now, the difference here is I'm looking for positive values. Why am I looking for positive? Because my function is greater than or equal to 0. So my positive values here are these regions. So when I write my answer, I'm going negative infinity to -6. Never includes negative infinity. Can it include -6? It's equal to, so it does. And then -5 to positive infinity. Okay? So I've done examples of each. I will write out, fill in the rest of the notes, and they will be available to you on our calendar. But come see me if you have any questions.